And welcome everybody back to Webinar Wednesday. It's great to be with you once again, talking about a topic that is really, really fascinating to me. And I think as we go through this, it'll be fascinating to many, many of you as well. And that is why energy is going to be such an important part of our economy and of our education sector here in 2021 and beyond. For those of you that have been on Webinar Wednesday before, you know that we're fascinated in part by something called Moore's Law. Moore's Law is the idea that the speed at which we process data by non-human means doubles every 12 to 18 months. Now, there's a number of different definitions of Moore's Law. That's just my personal definition. But this whole phenomenon goes all the way back to the 1800s and is continuing today. It was identified about 40, 50 years ago by a gentleman named Gordon Moore. He was an executive at Intel. And he came up with this idea that the speed at which we process data is doubling every 12 to 18 months. Now, if you've been with us before, you also know that we believe that that is a huge influencer on what is called the exponential economy, which means that in certain markets, products double in price performance every 12 to 18 months. My example for this whole phenomenon is my iPod. I still have this thing. It sits on my desk in my office in Mequon, Wisconsin. I got it in 2005, so now some 15 plus years ago. And it had about 7,000 songs on it. It was incredible. I could listen to that anywhere I went. I could listen to any song that I wanted to. And it cost when I bought it about $550, give or take. Now I want us to fast forward 14, 15, 16 years to today. Every one of us has a smartphone. Perhaps it's sitting on your desk right now. That smartphone, in my case, an Apple iPhone, costs about the same adjusted for inflation as that iPod did 15 years ago. But think about all the things that my smartphone will do. It's a camera, a calculator, a compass, a barcode scanner, a timer, a photo album, a tape measure. This is the whole idea of the exponential economy. This is what we mean when we double in price performance every 12 to 18 months. My smartphone does all of these things, has replaced all of these devices. And again, adjusted for inflation, about the same cost as that iPod I bought 15 years ago. So that is what Moore's Law is all about. Well, we have a phenomenon going on in the world of alternative energy, and this is called Swanson's Law. And we're going to touch in a little bit about how Swanson's Law overlaps with Moore's Law and how it is affecting everything in terms of how we derive our energy and how we will derive our energy. Let's talk for a moment about how we used to, and many of us still do, get our power in our homes and in our offices. We have a power plant, and that power plant is generating electricity. And that electricity heads over to a transmission substation, a series of switches and transformers that make sure that that power ends up where it's supposed to go. From there, it goes over high voltage transmission lines to a power substation, which is a little bit closer to your house. From the power substation, it is transformed and it heads over the power poles that may likely run behind your home. Perhaps they run underground, but that power and that electricity is then transferred to our home. And that is how, in this day and age, many of us do get our energy, and how for decades upon decades, many of us have gotten our energy. Now, we all have a meter that sits between our home and the power poles, and that essentially monitors how much power we're using, how much we're buying. And then based upon that usage, we pay the electric utility. And that electric utility is paid a price per kilowatt hour that is set by Energy Guy. So forgive the lack of gender neutrality in our name for Energy Guy, but for today we are going to call our representative of the electric utility Energy Guy. And Energy Guy sets the price that we pay for power, kind of. In a state like mine, in the state of Wisconsin, power is actually a monopoly. We can only buy it from one company. And so that's the case in many, many areas. And so Energy Guy can set the price of energy, but only by going to the Public Service Commission, a government agency who reviews the cost of Energy Guy's power, our usage of it, all these other variables, and then sets the price of our power. Now, as the costs of those variables go up or down, the fossil fuels, the raw materials we're using to produce that energy, the infrastructure that we use in order to transmit it and send it to where it needs to be, as those prices change, so too can our price of energy. But for decades upon decades, this is basically how the model has worked. Now, that looks a little bit different in the future. And that looks a little bit different thanks to many, many technologies, not the least of which is solar energy. And solar energy is absolutely going to disrupt in the next 5 to 10 years, if not sooner, this whole model. And that is because of what we call Swanson's Law. Swanson's Law works very similar to Moore's Law. It is the idea that solar panel prices decrease by about 20% every time we double the number of photovoltaic panels shipped globally. In other words, every time the global supply chain doubles the number of solar panels that it is shipping into the market, the price of those panels decreases by about 20%. Double the quantity again, decrease the price again. Double the quantity again, decrease the price again. And so we are seeing exponential reductions in the cost of solar power, and that is going on right now. This is going on to the point where I was with a futurist about a year and a half ago when we were talking a little bit about the future of solar power. And he said this. He said in 12 years, so that's by about 2030, we will produce 200 times the world's energy requirements using solar power. 200 times the world's energy requirements. We'll have 200 times more energy than we need using solar power. Even if he is just a little bit right, this is incredibly, incredibly disruptive thanks to Swanson's Law. So, a couple things to think about. Number one, you're going to hear the term behind the meter technology. Get familiar with that term. When it comes to energy, when it comes to alternative energy, that is a term that we are going to hear a tremendous amount in the coming years. Behind the meter technology. And the idea behind that is that the solar power, our solar panels, in many cases will exist behind the meter. In other words, that they don't exist on the other side of the meter where the power utility is controlling them. They may, but we can also put them on our homes ourselves and produce our own energy. That's what we mean by behind the meter technology, and it is going to be tremendously disruptive. Another term you might hear is distributed energy resources. Now, this is things like solar power and other forms of alternative energy. It's also storage. So, when we think about solar power, we all know that the sun doesn't shine every day. The solar power panels, the photovoltaic panels, work really, really well when the sun is shining, not so well when the sun isn't shining. That's leading to a desire and a demand for energy storage. In other words, when the sun isn't shining, we want to continue to be able to use the energy that we created using solar power. And so we need to find ways to store it. That technology is going to increase exponentially in the years to come as well. Energy efficiency is another version of distributed energy resources. The truth of the matter is, whether we know it or not, the appliances that we use in our daily life, the electricity in our homes, the way we light our homes, our dishwashers, our ovens, our water heaters, all of these technologies are becoming more and more energy efficient. They're using less and less power for the same level or for the same unit of output. That also lends itself then to grid management. So as we are creating power behind the meter, as we are decreasing our need for power due to efficiency, as energy storage becomes more and more prolific behind the meter, the ability to manage all of this on the grid, and in some cases, even to sell energy created by behind the meter technologies back onto the grid for others to use, is also part of distributed energy resources. So, if you're not familiar with those two terms, behind the meter technology and distributed energy resources, those are terms to pay attention to in the coming years. So, here is the challenge for Energy Guy. As we create more and more energy behind the meter, the costs of doing all of this stuff, of producing that power, of sending it through the transmission substation, high voltage lines, power poles, none of those costs necessarily go down. So, as efficiency is driving a decrease in demand, and behind the meter technology will drive a decrease in demand, the cost of producing energy for Energy Guy doesn't change. And so now we have a problem. And we have a problem because as we need energy from the grid, because we're not able to produce it using solar, the price of that goes up. Well, what happens when the price of something goes up? Demand for alternatives goes up. So the more we increase the price of the power coming from the power plant, the more demand we are going to create for behind the meter technology. And that is creating a huge challenge for Energy Guy. And it is incredibly disruptive and will be even more disruptive in the years to come. And when I say the years to come, the next 2 to 5 years, not the next 10 to 20 years. So, what that is now creating is an interest on the part of Energy Guy to come over here and start playing behind the meter. And as Energy Guy plays behind the meter, we will get more and more disruption in the whole world of energy. Now, we've seen disruption in the energy sector before. This isn't anything new. And that has led in the past to interest in alternative energy sources. I can think back 20 years when I was running a manufacturing plant. And in the period of about 30 days, my cost of natural gas went up by a factor of 10 to where a plant that was using about $20,000 a month in natural gas, all of a sudden that cost went up to $200,000 a month. A lot of that, as we learned in retrospect, was driven by speculation in the world of natural gas, but at the time none of us really knew what was driving that cost. You can imagine the huge increase in interest in alternative energy sources and in efficiency that was derived when a key cost of our product went up by a factor of 1000% or by a factor of 10. 10 years ago, we had disruption in the energy sector as oil prices started to skyrocket. And all of a sudden, people started looking at alternative ways to generate energy. And so when that was happening, we saw tremendous interest in alternative energy sources. In the last 5 to 10 years, thanks to advancements in technology and things like fracking and oil sands and so on, we've seen more and more natural gas come onto the system, less and less energy disruption, and we've seen some of those costs level out. But we have certainly seen interest in alternative energy sources in the past as a result of what was going on in the energy sector. The other influence, of course, has been concern about climate change, a concern about what we are doing to our environment or maybe doing to our environment using fossil fuels and carbon emissions, people concerned about their carbon footprints. And so we have a whole group of people that have been influencing legislation and policy on behalf of alternative energy technology for those reasons. Often these individuals are at odds with people on the other end of the spectrum who are concerned about making sure that we continue to have low cost of energy, that we can continue to make sure that we can manufacture products and live our lives in a way that gives us access to low cost energy so that our standard of living isn't adversely affected. But here's the interesting thing: these interests in alternative sources in the past were driven by spikes in costs of energy. They were driven by public policy on the part of certain individuals. Here's where this one is different. It is different because it is not being driven by cost spikes, but by exponential reductions in the cost of alternatives. And that is what is driving this new interest in alternative energy sources. And that is why I believe this new interest is here to stay. It is not a fad, and it is going to be even more prolific in the next 2 to 5 years. Because now we have the interests of the people over on the left side of your screen and the people on your right side of the screen that are both being fed. And so it becomes less of a political interest and more of an opportunity of everybody working together toward alternative energy sources. And that's why here at Webinar Wednesday, we have a prediction today. And our prediction is this: our prediction is that the demand for people who can design and engineer these systems, the demand for people who can install and maintain and troubleshoot alternative energy systems, the demand for people that can manage all of this is going to skyrocket as a result of distributed energy resources. The demand for these individuals will skyrocket in the next 5 years, along with the demand for those who understand data analytics and smart technology necessary to match energy supply with the demand in real time and in the future using predictive analytics. So, what does that mean for us in the world of education? How are we going to have to think about alternative energy and the way we deliver learning and opportunities in the employment sector differently as our whole energy sector gets disrupted? The first question some of you may have is, does Industry 4.0 apply? You've heard us talk on Webinar Wednesday and elsewhere about the importance of teaching students about mechatronics and industrial controls, of exposing them to industrial robotics and automation, and introducing them to the industrial Internet of Things and Industry 4.0 technologies. And now we're here talking about alternative energy. Does that mean that we should change our focus? And the answer is absolutely not. When we think about this whole system of how we will get our power in the future and how important it is going to be able to predict demand, to meet demand, to do it in a cost effective fashion, systems like electrical systems and learning on electronics and smart sensors and smart devices, how to get data in and how to get data back out, the control systems that manage all this stuff, wireless communication, networking, cybersecurity, the industrial Internet of Things, data analytics and automation, all of these technologies will be imperative in the world of alternative energy. And so whether students are learning this in an Industry 4.0 course or elsewhere, all of these competencies that they're learning directly port over into the world of energy as they do into so many sectors of our economy. This will be really, really important. No, we don't have to change course on Industry 4.0. If anything, Industry 4.0 becomes more important as our energy sector continues to be disrupted. But we do need to make sure that our students are familiar with these technologies, behind the meter resources and technologies, distributed energy resources. We need to teach them about solar and storage. We need to show them how we can manage efficiency and how efficiency is affecting our grid management. All of these things are really, really important. And so, what we look at in K 8 is what we always look at. How do we generate interest and excitement? We can teach students about solar and wind power. We can teach them about geothermal and fuel cells in really, really fun, interactive ways. Segments lasting 10 or 15 hours in a given semester. So they get a little bit of a snippet of what alternative energy is all about. It's all about gaining their interest, getting them excited about the technology, doing it in an interesting, hands on fashion, and doing it in a way that teaches competencies that are not just in the area of advanced of alternative energy, rather, but also teaching them things like data analytics and the scientific method and experimentation. What happens when I change the angle of a blade on a wind turbine? What happens when I change the amount of light that is connecting with a photovoltaic cell? And helping them understand not just the alternative energy, but also the data analytics and the decision making skills that are so important in every aspect of education. We can also do some interesting things in high school. And as always, we get a little more technical when we get into high school. We can start teaching about photovoltaics in a little bit more depth. We can talk about e mobility or electric vehicles, which are going to also be hugely, hugely disruptive, already are, and will continue to be in the next 5 to 10 years. Biofuels, we can teach them how we store energy and the importance of storage and the advancements in that technology. And then we get to our technical and community colleges. What should we be teaching in our associate degree programs, in our technical diploma programs? What should we be adding in the world of alternative energy? Well, I want us to first think about the growth in careers in alternative energy. And these numbers blew my mind. This is from Business Insider. So here we are in the year 2021. According to Business Insider, photovoltaic installers are expected to see in the next 5 years job growth of 104%. That means that we will need twice as many of those people in 5 years than we have today. So that's going to be huge demand for our students coming out of our technical and community colleges. That's a job, by the way, that pays $42,680 a year on average after they leave the program. Wind turbine service technicians expected to grow by 96.3% by 2026. That's a job that pays $54,370 a year. That one is going to almost double as well. So we need to make sure, if we don't already, that we are teaching these competencies and these career pathways in our community and technical colleges, that we're teaching all about alternative energy, that we are teaching about wind technology, and making sure students are understanding not just the technology, but how to install it, how to maintain it, and just as important, if not more important, how to troubleshoot it when it isn't working properly. We need to do the same thing in solar. Like we said, this behind the meter technology is going to grow in leaps and bounds. And I would say that Business Insider's prediction that it's going to double, I think that's probably conservative. I think that the demand for these people is going to go up even more, which will drive up the wages and drive up the need for us to teach this technology in technical and community colleges. Here again, they need to know how to install photovoltaic cells, how to troubleshoot them, how to maintain them, and understanding all of this technology, understanding how then to tie that technology back to the grid. And so we can use the photovoltaic and solar photovoltaic cells and solar power, not just to power a home, not just to power an office, but to sell that energy back onto the grid in a way that others can use it. And finally, geothermal. This is a way of using basically the temperature of the ground to either heat or cool or augment the heating or cooling of our homes and our offices and the other places in which we spend time. So geothermal technology is going to be really, really important here in the next 5 to 10 years as well. We need to teach all of these and have programs at our technical and community colleges that teach these competencies to respond to the upcoming demand for these individuals, and make sure that we're continuing to create amazing career pathways for our students and learners of every single age. But careers in alternative energy aren't just on the technician side, and there are huge opportunities on the technician side. But the training and development specialists, people teaching these technologies, demand for those people is expected to grow by more than 10% in the next 5 years. A job, by the way, that pays almost $61,000 a year. Environmental scientists and specialists who understand this technology, growing by more than 10% by 2026. A job that pays $71,130 a year. Civil engineers for renewable energy companies. These folks are expected to see 10% job growth according to Business Insider. $86,640 a year salary. And then we need people who are developing all the software, who are developing software around alternative energy, around tying it to the grid, around managing it, around predicting its demand, or around responding to that prediction. We need system software developers that understand alternative energy. 10% growth in that career category as well by 2026, a job that pays over $110,000 a year. So we need to make sure that we are teaching this technology at our four-year universities as well, and preparing our specialists and our scientists and our engineers for alternative energy. We can do that in several ways. And we need to make sure that this is embedded in undergraduate programs, in master's degree programs, yes, and PhD programs. And also, you are going to see tremendous interest on the part of universities in performing and continuing to perform research in alternative energy. And especially given, I think, the new administration being inaugurated today, a tremendous amount of funding for that research. And so we will see tremendous interest at the engineering level and at our universities in alternative energy as well. So, in short, we are going to see a huge increased emphasis in the next 2 to 5 years on alternative energy at every level of education. Interesting, our K 8 students in the technology, having them do projects, getting excited about the applications, getting into even more hands on, more technical experiences for our high school students, training those technicians, doubling both on the wind side and the solar side in the next 5 years. Huge demand for those opportunities, very good paying jobs. And so we need to make sure we're preparing our technicians, and we need to make sure that we are buffing up our university level engineering programs around alternative energy, because there will be a tremendous amount of demand there as well. So if we think about how we went from the iPod to a smartphone that does all of those things on the list in a matter of 15 years, we're going to see the same advancements in the next 5 to 10 years in the world of alternative energy. Smart technology is going to play a role. Swansons Law and the lowering cost is going to play a role. And we will get to a point where it is less expensive for us to produce energy using alternative energy sources than the traditional energy sources. And literally almost everybody becomes a winner as a result of that. So pay attention to behind the meter technology, pay attention to distributed energy resources, because this whole system that you see on our slide is in for tremendous disruption in the next several years. And as you know, at Webinar Wednesday, we love disruption. So with that, Melissa, I'll hand it back over to you. You can tell me if we've had any questions that have come over and anything that anybody has on their mind that they'd like to chat about.
Absolutely, Matt. And I'll just remind all of our attendees that feel free, if you do have any questions that you've been kind of mulling over or want to submit, go ahead and do that now. Matt, first question, you did talk a little bit about some of the technologies that, say, a technical or community college should teach in their programs. Do you think that this is a big enough disruption that some of these schools should actually be looking to create a dedicated program for new energy?
Without question. Yeah. If there isn't one already existing within the community or technical college, absolutely we should be looking at this. The truth of the matter is that this technology isn't going to discriminate based upon geography, based upon what state you're in. There's going to be demand for these people across the platform. And so if you think about a regional technical or community college wanting to make sure that as these jobs become available, as there's demand for them in the private sector, that they're able to respond with students, the answer is absolutely. If they're not already embedded in those programs, they should definitely be considered.
Great. And as they create those programs or look for companies to come on and help advise them, what sorts of companies or organizations can schools partner with to help advise them on the types of competencies they should be teaching?
Well, the first thing, Melissa, that's a really good question, is that, we kind of joked about energy guy finding his way behind the meter.
Yeah.
We're seeing that. That's going to be absolutely a big, big influencer. So whatever the power utility is, they recognize that their ability to have a sustainable business model is going to be 100% reliant on their ability to play across that entire spectrum. Because what will happen is, as demand for their energy drops, they're going to want to be in a position where they're managing that entire system. So you're going to see a lot of investments on the part of the power utilities over the course of the next 5 years. You're already seeing them, and a strong interest on their part in playing in that space. So that's where I would start and find out where the local utility is in terms of the continuum of alternative energy, what investments they're making, where they see needs for technicians. And then you're also going to see regional players across the board in every level of the technology, whether it's designing new technology, designing more efficient technology, whether it's building companies that are deploying the photovoltaic cells, for example, on homes. You're going to see tremendous interest there. So anybody on the building side, anybody on the construction side, those people will all be playing there as well. And then finally, to the extent we didn't mention it, any companies that are innovating in that space and creating new products.
Excellent. That's all we have for audience questions today.
All right. Well, great. Thanks for everybody for joining us. As you know, we always stay committed to keeping this thing to right around 30 minutes. You know, you're making an investment of a half hour of your time. We hope that we continue to provide really, really interesting content for you. You're not going to want to miss next week. We've got two great guests for you next week, both involved with the Wisconsin Department of Corrections, as we talk about the really important role that we can play in preparing individuals who are currently incarcerated for re-entry into the workforce. That is a pool of employees that our employers will do well to pay attention to, because there's tremendous opportunities there. And some of the paradigms and some of the misconceptions that folks may have about hiring people as they continue or they complete their paying their debt to society and move into private and public sector employment, some of those will be blown up for you as well. So that's going to be a really, really interesting content for you to consume next week. We look forward to seeing everybody next week on the next edition of Webinar Wednesday.